fine. So Jalia, in case you do not have my contact,
Yes.
let me share it in the chat. Okay.
Yes.
So that you can reach out to me anytime, and also I can save yours. Most importantly, create a WhatsApp group. Create a WhatsApp group. Make me admin along with you, and let other people who are in data science be able to join that WhatsApp group. Although you exist in the other main group, which is okay, but I expect more chaos on the other side than this side, and I don't want to link problems.
Understood.
So that's it. So we have a class coordinator. Well noted. You will text me on WhatsApp. Actually, as we share the link, I'll get to know that you are the one who tell you, and then we start from there.
Okay.
I request everyone, wherever you are, to briefly, I know you need to speak if you can't, but briefly put on your camera, briefly, and make sure you don't show us anything else, anything outside your face. Okay?
Madam, we are in the garden, some of us.
We want to see your face. I'm also equally putting, I hope my camera will work for you, but I mean, no, very bright place. Here in the staff room. Anyone who has ever come at, if you've ever come at campus, have you ever seen me? Anyone who has ever seen me anyway?
Me, I've ever seen you, I think.
Where did you find me? I'm seeing Saija. I've not seen even the face. Your hand was all over the place like this. I've got you. I'm waiting for Melinda. I'm waiting for Paul, Andrew. Even if you're in the garden, for as long as your face is there, we'll see the coffee plant, the banana plant, Edwin. I'm waiting. I'm also seeing other members here who are not yet seen. Please briefly put on so that we can move to the next level. I don't know whether my light is. I think I'm more visible. So, who has not put yet? I don't want to deal with the AIs. So,
Adrian here. I'm one of the people that are in the farm.
Yeah.
Ivan, Melinda.
Melinda. I have not seen you. Andrew, I've not seen you. Paul. Okay. Jali, I'm waiting. I know you are in there. Okay, fine. How is Saumo? Let me see who is not. Are we done? Who has dodged? Arnold.
Tugume has not put.
Yes.
Atusimire has not put.
I think they were doing funny things. Okay. No, I've not seen you properly. Put back. Then Andrew was not dressed. First one to put his video, the camera on. Please comply so that we do not waste out of time. And at least you've seen each other. Maybe you've never seen each other ever since. So we've got a chance to see you. I'm seeing Simire is there after a careful preparation to show up.
You didn't see Adrian.
You want to see him again?
What do you mean you didn't see Adrian? I'm here. You showed my face.
No, I didn't see the video.
You can put back.
This is Adrian. You see, this is me.
Oh, you're in the garden.
I'm in the farm in Toroko.
Okay, so I've also removed for those who will join in later. Maybe they will get a chance again next week. And for those who have not showed yourselves next week, be prepared because I don't forget actually. I don't forget that you did not show your face. So we are here for a question to code operating systems. One of the things that our class coordinator will be doing, I think Edwin, you can mute yourself. Madam Jalia, you will help us create a WhatsApp group. That is number one. Keep people who are attending. It is important because I don't want people to show up later and start claiming they need help from me when they were not attending. I will try to put on here the attendance plugin, but we need to know people who have not been attending. You are approaching cut one. So you need to have some class list around. Maybe they will inbox, they will put their names and IDs in the chat as you copy and paste in Excel as a way of gathering our class list. And for presentation and participation, I have to award some marks. The rest where we have notes on Planet. The notes that are on Planet, I will also be sharing them in the WhatsApp group. The summaries in the PowerPoint, but I will also share another file, which is not on Planet, with some details of the course and the notes. With the PowerPoint one, there will be some links, and I think even when you check on Planet, you will also find links there that lead you to particular videos on YouTube to describe better some concepts. I need to put a disclaimer here that this module called operating systems, it is easy to someone who has put in effort. I'm not scaring anybody. It is easy for someone who has put in what? Effort. Relax, it may tend to be a little bit challenging, not hard, but a little bit challenging. The reason behind that is because we talk about things that we cannot see and we cannot find. So some people tend to find the and terminologies contradicting one another, seemingly contradicting, yet they are not, and the mix-up happens. But there's need to to have more focus every time we are continuing, so that you can be at the same pace with me. It is also kind of wide. That's why I encourage attendance, because when we cover a wider thing, even when it comes to examination, you can find yourself swimming in the sea when actually whatever you revised has not appeared, and you get poor grades, which is important to always attend to go through them and even research more. That's why I was able to beef up with the links and videos to try to express those ideas better to you and during your revision purpose. You can even download them and watch them at your own timing. So my names, I guess you know them, but I have to mention them as you can see them there on the call. I'm Nabbanja Teddy. I'll be taking you through this course called operating systems. I understand, and I'm very sure everyone understands what operating system is, and you've heard of operating systems severally, very many times, and you have even used the operating system on several occasions. So you may be wondering, what are we going to cover in this course unit? Quite a lot. We are going to cover quite a lot. But I would request whoever cares to share with us to tell me, what do you think we are going to cover in this course unit? In a brief, a few statements, like 2 or 3. What do you think we are going to cover in this course unit? Because when we do not tickle our mind at the beginning, You may be just leading somebody anywhere without any grounded what? Vision. So if we can align ourselves with what we are going to cover, what we are supposed to cover, and also get rid of the weird expectations, the better for us at the beginning. So can I get to hear from anyone? What do you think we are going to cover in this course unit? Share with us what you think we are going to cover, please. I'm waiting. Yes, please. The types and their functionality. Thank you. Any other person who has thought of something? I am in the staff room here, and it looks like people have their personal meetings outside. Allow me be telling them to exist as you also think about the answers. All right, I'm back. So let me know. To cover. Of course, you have some shame and you don't Google. Some people are going to Google right now so they can retrieve everything online. Google, please tickle your mind. For the person who's in the garden, have you disappeared for good?
I'm still here.
Talk to us. What do you think you're going to cover? Everyone must have an idea.
Basically, from our own perspective, I expect the inner workings of an operating system. How do they work? The in-depth, probably not too much, but the in-depth look at how does really an operating system look like in its way of operation, the exchange of information, the instructions, how they happen, the hows and when they happen. That's what I'm expecting, probably in different types of operating systems.
Okay, thank you. Any other person? Any other person?
This is Andrew speaking.
Yes, please.
I also don't deviate more from Adrian. I expect to know that just the introduction, the introduction about operating systems types. If I don't know if we are going to install, but I also would expect to know how you install but some operating systems like Windows from scratch. Yeah, and going deeper.
I don't know deeper. Does it require a spear or something, the deeper part? Well, thank you. Can I imagine that others do not have any idea? Should I take that the rest who have not spoken, they have no idea? They are ready to be led as the followers of the module?
Ivan here. Me,
Yes.
I expect to know the science between the operating systems, how they work, why you have different, the comparison between different operating systems. I also expect to get some recommendation, the best operating systems from you or from the content you're going to see. Yeah.
Okay, thank you. So the rest are going to be followers. Can I take it that we have followers here? I should call myself a savior. I'm going to save people who cannot object what I say.
No.
Eh. Eh. Mm. You would love to know more about it. Ah, yes, knowing you will know, but not now and not at this time. Not now and not at this time. Any other person willing to communicate, or I take over from there?
Hello.
Yes, please.
Yes, I'm expecting to know how an operating system is able to coordinate all the peripherals, all the things that are connected to the computer, how it is able to handle different things. Because to me, I think an operating system is what controls everything that is a computer is able to do. So I'm expecting to understand how it is able to do that. Thank you.
To do that.
Mm.
Thank you. Thank you too. Do I need to ask for more contributions, or we can proceed from there? I think we can proceed from there. Anyone willing to share with us?
Yes.
Please do.
Jalia here.
Yes, my dear.
Also, know more of how these operating systems handle the memory management, the file systems, and those output operations and input.
Mm,
Yes.
okay, thank you. Is there anyone who has not spoken yet? Anyone who has not spoken yet and you wish to share anything? Okay. For the sake of this course unit, I don't always give a direct answer, okay, at the beginning. I always first solicit your opinions, and then I'm able to give you a conclusive vision for this class. And with that, I always ask a few things. Do you know what is called software? Do you know what is a software? Now, this will respond. Do you know what is called a software? Signal me, you can unmute and answer. We are still in an interactive class. No formalities. Do you know what is called a software? Do you know what is? Is everyone hearing me? Mine. Really, how come? I'm on this stuff.
It keeps on dropping.
Try to put in a cable to secure my connection. Let me secure the connection. Okay. Am I better? Okay. So if I'm better, then I'm requesting some answers from you. Do you know what is a program? Just saying yes or no. Then, do you know what is an application? Oh, do you? No, you. When you laugh, Edwin, I don't know what it means. You either say yes or no, because laughter.
Because to me, you've asked the same question. Apparently, they are different, so that makes me laugh.
Yes. Yeah, there is quite a difference, by the way. What is a software? What is an application? What is a program? They are different in context. They may seem to be the same to general, to the general perspective, but they are different. They have unique uniqueness, and the capabilities vary from one place to another, from one aspect to another. And then if we talk about software, um, if we know what is a program, we know what is an application, we know what is a software, then we go to what we call an operating system. I always start with this overview by explaining that from a basic point of view, unfortunately, we can't see each other, but with the people I've been with, you talk about an operating system, they think something else. You talk about this, they think software, they think of anything basic. So let me put it clear. From a smaller perspective, we have what we call a program. A program can be piece of code, organized piece of code to solve a single task. Sometimes a task is referred to as a program, a problem. So you can have a program that can problem or a task, and that is called a program. But you can also have a program that can solve many tasks or many problems. That is a program. So a program can be a smaller component or a bigger component. In many circumstances, when we talk about a program, should be dedicated on solving a particular problem of the end user, more like an application. So when we come from a program, we go to what we call an application. An application can be a combination of different programs that are organized to solve a number of problems. From a program, we can see a compiler, we can see as well a compiler cutting across to an application, but the most common application worldwide, I would say, is Microsoft Office, because it comes in a package. It is a combination of a number of different programs, and all those programs have got several smaller tasks they are performing. So at a smaller level, if we are creating our canopy, which is facing down, we start with a program, and then we are able to come to an application, and then we come up with a software which is on top of the application. A software in its ideal situation is supposed to be a combination of applications more than an application per se. It should be a fully-fledged package of different applications targeting to solve the end users' business needs, And when it comes to a software, it is not something that can ideally be dealt with under simple circumstances. For example, no financial implication involved, no much time spent, or no need to interact with the business environment, among others. Because when you're coming up with a software, it is dealt with in the form of a project-based venture. If you have heard of a project, or you've dealt with witness that a project may not necessarily be handled by one person, that is number one. It does not end within a simple period of time, like 1 day, 2 days. It takes some time because it has a number of different phases it goes through to be accomplished. And then as well, a project involves a group of individuals who can contribute knowledge at different levels. It requires you to have full knowledge of the business environment where you are going to implement that project. So when we talk about a software, that's what at this at. And I believe and trust that you did software engineering prior to this course unit. So I'm just making an overview of that for caption just. Now, when we talk about a software, one of the examples of softwares that we can talk about, softwares can come in a number of ranges as well. From a developer's perspective, we have a program, we have an application, we have a software. Then from the end user's perspective, they always talk about anything to be called a software, ranging from simple and to sophisticated, they are all software. So we need to have that perspective noted out, that for us as specialists, when we talk about a software, we actually intend something bigger than what is smaller to the end user. So when it comes to types of software, I also believe you know them very well, where we have application software, we have system software, we have utility software, and any others that you may have come across, and any others. Please underline that word, and any others you may have come across. But for this purpose, we are going to acknowledge the three, that is utility software, we have application software, and then we have system software. You will forgive me for the throat problem, the sound problem. So when at a basic level, we see the utility software just being any kind of, I prefer to call it an application that is added onto to support a given functionality of a computer, not necessarily to be able to perform major functions, but to support the proper functionality of the computer. Under this, some people prefer to add in antivirus, while others prefer to leave it under application. So depending on the source you go to, I would classify antivirus to be application software, while other sources group it into fragmenters. We have backup software, to name but a few, depending on the field that you are in. If you are in network, software is available to support. If you're in database, they exist. In system admin, they also exist. Yes, we have a Saicha.
Yes, but I was wondering if are you supposed to be displaying something?
Not really. We haven't reached there yet.
Yeah, because the way you are flowing, I thought you're presenting.
No, this is coming from my head. I'm giving you the overview.
Okay.
So relax. I'm still trying to motivate you. We haven't reached the gist.
Okay, understood.
So when we move from utility, this is content I'm talking about is for first year. You did this in introduction to ICT, I believe. So it's not something very new. So when we move from utility, which is the basic, which does not support many functionalities, then we go to what we call application software, where we see it designed to facilitate the end users needs, and that's where we find the Office package, among others. Here we also see other applications that we always put on our computers to support the functionalities. For example, you have compilers, you have the programming languages, to name any that you want to put onto the computer. We have even a single browser. We can also have as anything you want to install. Some people have music related, any application you can bring and install on the computer has that one function, but several others are incorporated. And then with what we call system software, being the main controller of the computer. When I'm explaining system software, in other words, the basic example, the only example existing is what we call the operating system. Now, with the operating system, it has a definition depending on where you can visit to get the definition, but operating system can be described, not only defined. You can only use a group of statements to describe operating system. So what is operating system in this case? Operating system, first of all, it is a type of system software that is designed and installed onto the computer as the first software to be able to activate the hardware, to be able to support, to provide a foundation for supporting other programs and applications and softwares, to be able to coordinate the different hardware components and software components, to be able to monitor the functionality of the computer, to be able to take control of or take charge of memory and file management, to be able to provide security, to be able to handle process management and executions that are carried out within a computer. As many as the statements that you want to put across, but most system is supposed to provide a user interface for the end user to be able to interact with the computer. So as I said earlier, the operating system can be defined using a group of statements. So anything, whether you have put 100 or 20 or 10 or 5, for as long as you're describing it and it is somehow distinct from any simple application, that is an operating system. From what the statements I was using to describe operating system, you can clearly see that it is a very important component of a computer. And therefore, this course unit as operating system, knowing what an operating system is, and also look into details how an operating system works in relation to a computer system and also in relation to the end user. So that was the preamble of operating system, what this course unit is all about. Did you grasp anything? Did you get anything? Really? Okay, so I guess those who have not signaled, they are still wondering, did she finish talking? And probably they never picked anything, but with the time you will pick. So a summary is this operating system as a course unit is supposed to usher you into understanding operating system in general and how it functions towards the computer system and the end user. That's the vision of this course unit. And when it comes to operating systems, I would like to draw your attention mainly away from any other gadget apart from a computer system. Are we together? Because we have a number of different operating systems. Every electronic gadget has got operating system. I don't know whether you agree with me or not. When you look for watches, they have this capability phone it has. You go to now TVs, we also have fridges system. So I want you to restrict yourself to the operating system that is directed to the computer, not your phone, not your smartphone, not anything else, because there we can find a little bit of overlap in terms of scope. So we need to determine our scope strictly to the computer system. And at this stage, that's where I'm able to ask to give me, everyone has to give me an example of operating system that you have ever used or you have ever known. Who is starting? Who is starting? Who is starting?
Windows.
Which windows? The ones that are behind me here.
Windows operating system. I've used Windows 11.
Mm-hmm.
Yeah,
You were complaining about my network, but I think you equally have poor network. But thank you. Noted. Noted you have Windows 11 there. Yes, another person. Great. Another person. You can mention what you've used or what you have known about, you've heard about, or you've read about. So everyone must give me an example of operating system.
Ubuntu.
Ubuntu. Thank you. Another? Kali. Thank you. Another? A Mac OS. Thank you. Andrew, you're saying something?
XP.
Yes?
Windows XP.
Windows XP. Thank you. Another? Do we have another? What happened to Edwin? What happened to HR?
They've already mentioned mine, the Mac OS.
Yeah, there are
That's the one I
others. You
use.
must have had some people as well.
They've mentioned the two that I've ever used. I've been using Mac for over 10 years.
Okay, how about Jalia? Jalia is resting.
I think she got some problems. She's not on the call. Maybe she has gone to pray.
She has gotten caught up. Okay. That's being put aside. We have several examples of operating systems, but mainly we are restricting ourselves to what? To computers. During Android, does it exist in computers? Well, surprisingly, they say so.
Android is in computers.
Thank you. So they said Android. Which other? Of course, there are those elementary that the vintage, for example, Microsoft DOS. Andrew, are you still saying something? There we have vintage software as well. That is vintage operating system like Microsoft DOS. We had also had the elementary Windows 7, Windows XP, Windows NT, Windows 98, Windows 97. You know, those old versions. We have, when it comes to Linux, we have Ubuntu, there is Kali, we have the there's another one called Digora, the what? Diro something. I heard of it from my students, among others. So when you are talking about operating systems, as now, starting from today, please don't be limited to only what you have used. That's what it means. To understand you as a person, we don't start with you and end there. We need to understand your foundation, where you came from, your history, and where you are, and then where you are heading, if you have a future anyway. So we don't limit ourselves to what we know. Equally, when I share the notes, you may find that there are some which are mentioned, they are very old. So don't complain, because they have existed and they are still existing, if they are, and they have ever existed. So even the current one. So what you will do is you just update with the current ones, and it is upon you to always update yourself. Don't go with the past or only the present. So now we have issues surrounding surrounding operating system. And one items that we need to leave unnoted, that we can't leave unnoted, is what we call versioning. I tend not to define software versioning for you, but I prefer to explain it so that you can understand it. So software versioning, I give a contrast with our secular life. You know the music industry, all right? They always produce songs, and if you have an original song, you can come up with a remix, you can come up with another version, and or any other that those concepts that you know regarding music, because music. When it comes to software production, we have what we call versioning. Now, with the software versioning, it is an approach. It is a technique that software engineers use to be able to revise the current operating system version, and they are able to add improvements and release a newer version with similar functionalities but advanced functionalities within the newest copy, which is always given its code and given a versioning number. That's why you see there's been a number of series of Windows operating system, from Windows NT, Windows 98, Windows 97, Windows XP, Windows 7, Windows 8, Windows 10, Windows, those are called versions. So anytime you hear anything called software versioning, that's what it means. It happens in any kind of software, and it also happens in operating system. In contrast, you can also refer to the operating system that you have onto your gadgets, the phones. They also have operating system which comes into different versions. That's why you keep on upgrading, and I think the word is upgrading. I don't know whether everyone has ever upgraded your phone. That is good if you have, but there are different versions, and the versions work with a compatible specified model of the computer. Put that word called the model in what? In brackets. A specified model of what? A computer. Equally, if you are to relate with the phones, the given software can only be compatible with your phone if the model has been put into consideration during the testing time of the produce of that software. So we can leave any other gadgets, but within computing, softwares have evolved over time. And that means that there's a history of software. The history that you had in introduction to ICT, it still exists here. Only that for us, we can only be picking out one item, which is operating system. So the operating system also has got history, and the history of that operating system dates as much as a given model or technology of a computer was still valid or was still having purpose. So when it comes to operating systems, we have versions as well, and equally in other softwares, we have versions. Now we have operating system. There is one aspect I want you to go ahead and research about. You might have already covered it in other questions, but make it stick into your mind. Go and research about something called software. We have outsourced, we have open source software and commercial software. Go and read about commercial software and open source software. You can equally get examples of open source software, operating systems, and any other if you want. And also get examples of commercial software in terms of operating system and any other that is not an operating system. That is very important for you. Whatever I'm saying, it is very important for you to ground yourself clearly in understanding operating systems, because the functionality of open source software and commercial software can be the same, but the mechanism can change. So I don't want you to start conflicting with my statements. I call it you conflicting with my statements, carried what we call garbage in, garbage out. All right. So if you do not, and you cannot know the functionality and what differs from what to what, you may start conflicting with me as I'm explaining, which will cause a little bit of uncertainty. Think you are right. Yes, you are right, but in which interest are you offering the statements or the answers or the comment? Is it in terms of open commercial software because they have similar mechanisms, but they have some uniqueness on performance of some of the things. So that should be put at the back of our mind. Open source and commercial software, very vital for us to understand. So I think that one sets a foundation for our operating system. And the rest I'm going to take you through briefly as our introductory part. As I said earlier, allow me to share with you. I'm sharing the screen now of the notes version, which I will equally share with you. And then also the PowerPoint, I'll equally share with you in the WhatsApp group. And you can even find them on Planet, okay? So any version I would choose to share with the PowerPoint. When I come with this version, equally welcome it. Yeah, so I guess you can see my screen very well. If you can see my screen, let me know. Okay, thank you. So let us progress. This is the notes version of it, which has more details. So we've already explained what an operating system is, and what I was offering prior to what we are saying was a preamble or on an overview to usher us into what we call operating system and our learning. I will also be sharing a course outline together. In case I forget, you let me know. I will share everything with you. So here we see a definition I believe everyone can read. I don't like reading because I just want to highlight most of the things I've already talked about them. So you can see when we are describing an operating system, we are not only limited to one statement or a definition. You can see a lot of different statements coming in. So either way you want to explain it, some people can prefer to say it is just between a computer user and the hardware, and they end there, but they can add, you can add on more and more. When we are in class, I always ask you, the students, unfortunately now for us we are kind of limited. I always ask the students when they are giving me answers, whether whatever they have mentioned when they are answering my question can be easily understood by their grandparent in the village, because you know how inquisitive our grandparents are, grandmother or grandfather. Whenever you are doing something like, what is that? Talk to me, what is that? So if you are to explain to your grandparent, the approach I want you to use to understand operating system is if you are to explain to your grandparent, your grandmother or grandfather, the statement you've put across, can that person be able to understand what you're talking about? Whenever you see my grandmother cannot understand this, please add more flesh. Add some simpler statements to make it very clear. So that's why I tell you, you're not restricted to defining an operating system with one statement, but rather a group of what? Statements. So here you can basically see that an operating system is involved in a number of different tasks, ranging from file management, memory management, process management, handling input and output, controlling peripheral
Is it only me or she's off? Oh, if you can hear me, that means I'm not the problem.
a bit, let me first receive a call. So if you are recording, the person who's recording that side, you can save me. Let me not record now because I'll have broken things. But I can try. You never know. You might also get a clean
Problem.
Let me also try to record.
But to let
So
you know where you had stopped, you had stopped, I think, somewhere to do with us researching about the functionality and then the mechanism of the open and commercial software.
Oh, really? I shared the screen and I was talking massively.
That's where we
I never
stopped.
explained. I never explained what is on the screen now.
You had started going through a couple of things, but realistically, the other part is where you had stopped.
Okay, so now let us switch to this mode here. This is an overview here. As you can see, that a definition does not only come into one statement. There are a number of different components, different commas to explain, but all of it should be aiming at making someone understand what an operating system is. Of course, we have got a number of different examples of operating systems, ranging from these that have been listed, because I may have told you vintage is the beginning of everything. So you should be able to have these, and then the newest ones, which we've talked about. Of course, we have Windows XP, your Windows 7, Windows 10, Windows 11. Then we have the current ones in the iOS. There's also Android. So research and add on that list. You should be well comfortable in expressing yourself as far as examples of operating systems are concerned. And also, if you are working elsewhere, it does not only limit you to what you are using in your workplace, because at one time you would wish to switch jobs, and then when you go to another place, you are totally green. And then you shame us from Cavendish that what kind of person is this who is having a bachelor's without knowing all these operating systems existing? So every day, plan to be well equipped with the current knowledge as far as your field is concerned. So we can also get a definition of an operating system. As I said earlier, any way you want to fashion it, it can work for you. So I don't intend to read for you anything. But as one way of expressing what an operating system is, this is how we can view an operating system. We have our users, user 1, 2, 3, and to name but a few. All users are expected to interact with the computer system using a particular kind of software. And also this software is the one that enables the hardware to be able to work. So when we look at the users, they interact using a software, and which kind of software? It can be system software, which is an operating system, and it can as well be application software. But in most cases, you cannot interact with the computer without having a system software in place. So when we have system software, we have operating application software, together is what composes the component of a computer system, which is called software. And it is from this interface that the operating system is capable of managing or monitoring or even being able to enable the other applications, the other softwares, and the hardware to work together. So any end user who wishes to interact with the computer has to be using indirectly software. You at your end, you will see you're using hardware. For example, you're holding your mouse, you're using your keyboard, you're saying you're printing, but indirectly you're using the software to be able to command that hardware to function. So when you talk about hardware, there are a number of different hardware devices. Of course, you already learned about the input, output, storage, communication, etc. But here they have been summarized in the form of CPU. I believe you know what CPU is, central processing unit, in terms of RAM to represent memory or storage, and also input output devices. Now, when you talk about input and output devices, we are now having a group are highlighted into that one package to mean any detachable device onto the computer is categorized into the input output what aspect. So anything, when you look at your laptop or you have a desktop computer, anything you see that you can afford to attach to your computer enters through what we call the input output interface, and therefore they are categorized as input output devices. So that's where you see I stroke or to mean input output. So we have a number of different functions. Of course, there are very many. Even in other resources, I will give you when there are very many functions. We have what we call memory management, we have process management, device management, file management, security, control over system performance, job counting, we have error detection, we have coordination of other software and users, etc. All these ones are done, and even more. And as we progress, we shall see that besides the functions of an operating system, there are also there's also another category which we call services of an operating what? System. And also we have what we call properties of an operating what? System. So a property, a service, a function, they are all like ingredients that make an operating system become more valued or more valuable towards the computer system and the end user. Now, when you talk about memory management is performed in a number of different ways. I always highlight this last part here. An operating system is responsible for knowing what is happening within its memory. First of all, we have primary memory, we also have secondary memory, and it is capable of knowing which part of memory should be given to which job or which task or which execution that is being asked for. And besides knowing which part of memory and also partitioning the memory accordingly, it is expected also to deallocate. Deallocate means taking away that memory. Have you ever imagined a situation where you have a computer that you've used for over 10 years and its memory has remained not expanding as the days are moving or the hours are moving, because the operating system is capable of reusing the memory by, first of all, partitioning it, and then secondly, allocating it, and then after it deallocates it. When it deallocates, it means that if a process or a job has been executed and has ended, the memory shouldn't be left in a busy mode. It should be taken out to be declared free for any other job, any other process to utilize it. So that's what we call allocation and deallocation. We shall also see in details how the allocation is done, how allocation is done. We shall see memory allocation strategies. We shall see a lot of things when it comes to memory management. For now, let us explain the function itself as in its embraced way. Another function is process management, and we see that in the process management, we have a number of tasks that have to be performed at the same time on the same device. All that is enabled by the type of operating system, and it does that through what we call process scheduling. We shall also discuss in detail process management as a function of operating system because I told you we are supposed to learn how an operating system works. So all the functions and the properties and the services of an operating system are going to be studied in details as a topic one by one to understand clearly what an operating system gets involved in as far as that function is concerned. So here on process management, we see that it does a lot of things. Actually, this is one of the widest topics we shall meet, because a lot happens. Anything that happens to run into a computer environment, it is supposed to be named as a process. It is declared as a job. It is declared as a process. And that process goes through a number of different stages, preparation, then it being scheduled, it being executed. There are some processes that have to be rescheduled through a process called preemption and preemption. There is switching of different status of different process. We shall see what we call context switching. There is a process memory management. We shall see that. How is memory managed? There is process control block. There are a lot of things, anything that runs within a computer system, including those that come from the end user, then those that are generated by the system files, then the program files. We have those that come in as interrupts, for example, printing or sending in a communication from any other device on a network. All those are considered as processes, but how are they handled by the operating system? They are handled by the operating system through an activity called process management or processor management. Then we also see device management. We all know that an operating system doesn't run independent of the hardware. So whether input, output, storage, communication, name it, they are devices that are recognized onto the computer. So the operating system has to take charge of all these devices. First of all, it is supposed to identify, acknowledge that this device exists. It should be able to identify and know its working status. It should be able to know its purpose it serves. It should be able to know where it is supposed to communicate, how it communicates, when to allow it to communicate, and when not to allow it. If it is to be allocated to another process or be allocated to a given function, how is it done? And when it has executed, how does it conclude its execution? So all that comes into what we call device management. So this does not only apply to input devices or output devices, but also internal computer devices. Now we move on to another function, which is file management. This is somehow related to memory management, but memory per se, it is taken at a higher level, at a bigger perspective. When we talk about memory, we are referring in big chunks. That is like in terms of RAM, which comes in terms of previous we used to have MBs, GBs, now we have TBs and teras, all right? So to name but a few. So that is memory management in large quantities. But now there is what we call file management at a smaller level, because even if you save a file that has only one letter, it is called a file. And the operating system is capable of identifying and knowing it all around that given file by knowing the size, knowing the extension, knowing the program that created it, knowing the content, to name but a few, and without confusing it with the other programs. So it is supposed to take track of what happens in terms of files. Which files do I have? What category of files? Which device requires this file? How does this function, this file get accessed? How do you access the file? How do you retrieve from a file? How do you close? How do you save a file? All those related details are known by the operating system. That is file management. Now we have other important activities that an operating system deals with. We deal with the security, deals with their performance, those functions that we cannot even get to know. Then we have what we call job counting, error detecting. We have coordination of other softwares and users, because sometimes we are on a networked environment where we can access a lot of resources. Now, at this level, I would like to declare that any component that is attached onto the computer, it is referred to as a resource. It can be software, it can be hardware, it can be users. If you're on a network, you can be more than one user on a given computer, or a given resource, which is called a file, or data, or information, or even the software itself. It can also be a resource because it can be shared, for example, a database. So all that, all those services are provided by the operating system. Now let us see the types of operating system. Now we have a lot, just like I told you about the history dating back to as far as the computers were started. So does the operating system. So operating systems have existed over time for a long time, and the way we identify the operating systems varies from one to another based on the mechanism of their function, how they execute their functions, how they execute their tasks or processes. So the first operating system that was recognized were categorized into what we call batch processing operating system. With the batch processing, they could do function in a way that that is not continuous per se. Rather, the computer would be set up and it could receive as much as the declared number of instructions or processes that need to be processed until when the minimum specified has been reached. That's when the processing can take place of those. Imagine a situation where you have started your computer and you have delivered different tasks, but because it only executes up to 8, when they have made it to 8, it would wait even a whole day or 2 days or 3 days without executing those jobs. So batch processing had its advantages because by then it was the only sun that could rise within the whole world. So people utilized it and had it served its own purpose, but with the time it was outlived. I also wish to declare that with batch processing, they were single programming operating systems. They could not allow execution of one job at a given time. So there are a number of problems that came around with batch processing, like these ones. I'll even share with you more others. Even the videos, the video links that I've shared, you'll find more of those disadvantages. Then as an improvement, batch processing led to what we call time sharing operating systems. This being unique in a way that they could enable many people to be able to execute jobs, but in intervals. You would find that one person would use a given computer to execute a job, and even another person would use the same computer to execute the job. Remember, with batch processing, those mainly dealt with the operating systems like DOS, where one person would log in at a given time, while with the time sharing, you would log in at least with more than one person. And some simple multi-programming and multitasking was experienced in here. However, there was still more demand because the more you use a given item, the more you find some loopholes. So it had some advantages, of course, that were that overshadowed the batch processing, but also there were somewhat disadvantages. Those disadvantages and the advantages that the time sharing brought on board were to lay a foundation for distributed operating system. Now, with the distributed operating systems, this is where there was utilization of multiple processing plants or processing centers, processing systems, where multiple processing systems will support multiple users at the same time. That meant that there was multiple of processes to be executed or jobs and across a distributed platform. And this would use dedicated processors or would use dedicated computers, but also coupled it together to form a single computer system. This existed at a given time. I remember also I've ever used a laptop that had over 2 processors, and and it would support when it would be on a network. It would be able to choose depending on which job you want to use. You are executing. You could be able to dedicate one processor for this and another one for background processes, to name but a few. But also with these distributed systems, they were not good enough. They had to come in with the other better version to support distributed environments, that is networking environment, by coming up with what network operating system is. Of course, somebody named the networking operating system here, and we have also very many versions existing, and even those that are already using at your workplace, you know. So network operating system, This is a specialized operating system that was designed specifically to work on servers, because every time we have a distributed environment, it means that we have a networked environment. It means that we are connected. We are connecting one computer to another to support each other in terms of sharing the resources in terms of files, in terms of internet, in terms of data, information, to name but a few. But when you do not have a single power or a single muscle to support that network environment, was a hurdle. So that's why network operating systems were invented, were produced. With this, they were specifically meant to run on servers, which servers were also specialized computer devices that were produced specifically to handle large sums of data and many users at the same time, with some amplified and advanced security features to allow or to avoid over manipulation or exploitation of the different resources that can exist on that network. So the network operating system comes coupled with the massive data manipulation, massive data computer users, then massive security features and other networking capabilities and functionalities, which may not be supported by an individual computer. For those who have already practiced, you have already seen or utilized and known the purpose of a network operating system. And I believe you even know a number of different examples beyond even what has been listed here, because these look to be a little bit legendary. So there were also massive, there are many massive advantages of this operating system that you may not exhaust. And then we have real-time operating systems, which allow actual processing as data is being gathered. With these real-time operating systems, they allow collection, they work in a sensitive manner, and they are deployed and implemented in very sophisticated and sensitive data environments, where they are able to apply some level of intelligence to be able to know and act, respond where a need arises in terms of after analyzing the data that is currently available, and then it can be able to act before even it is triggered by a human being. Real-time operating systems, they are mainly implemented in very heavy data environment, information environments like airports, airlines, let me say also international banks with very huge sums of data, like in stock exchange, and then also in military war zones or missiles, so that they are capable of gathering data. They look at the incoming data and they are able to analyze and predict what can happen at a given time, and where necessary, they are able to advise by giving a decision or even quickly act to avoid any catastrophe, because they have that AI capability. So those who may have, you may research about the airline, the airline systems, you research about some sophisticated bank systems, then you research stock exchange operating systems. Then we have to, with the military missiles, where they send the rockets, they can reach a given level where they cannot progress, and they are able to determine whether we can return or we can now bomb the place, to name but a few. That is a real-time operating system. Now we have what we call the real-time operating systems. It comes in terms of two categories. We have hard real-time and then soft real-time. All these ones, they come into a number of, basically, depending on how you want it to be explained. Now, in the interest of time, I want us to end at 4:30. Okay. I would like to welcome questions if they are, and if you are still on the call, by the way. Are you still there? Because I'm not seeing.
Yes, we are still on the call.
I would welcome some questions so that next time when we meet, we can start on the services, we can go to properties, we can go now to other details, and then also usher in the process management and other details, to name but a few. So for now, I want us to end here in preparation for our next lesson.